minute. All right, so today we have engineer Ismail Hakeem Babatunde, who is a graduate from the Federal University of Technology, Mina, in the Department of Electrical Engineering. And he's also undergoing his master's in system engineering at the University of Lagos. Now, his experience started from field activities, field service engineer with specific tools and techniques. Then he now moved on to IPT Power Tech, all in the telecom sector. From there, he was moved to facility manager with Lambert's Electromet. He also served as the head of operations with AQNA Resources. He also served as the supervising electrical / solar engineer with Development Africa. He also joined the Power Cell as the service engineer, then later promoted to the lead design engineer, and also recently promoted as the assistant general manager. Engineer Hakeem is also current certified facility manager, and also a member of a Chartered Institute of Power Engineers in Nigeria. Wow. So he is well-rounded experience, and also to add, he is also a RETI alumni, one of the first beneficiaries of the RETI Wave first batch cohort, right? So Engineer Hakeem is here with us on the call, who is well experienced in the subject matter for today. So with a warm welcome, I want to warmly invite Engineer Hakeem to take over. Good afternoon, Engineer Hakeem. You're welcome to the call.
Good afternoon, everybody. Oh, can you hear me?
Yes, we can hear you, Engineer Hakeem.
Oh, okay. Just a minute.
Engineer Hakeem, are you still there?
Yes, I can hear you. Okay.
Yes.
Good afternoon, everybody.
Good afternoon.
It's a pleasure to be among the leaders today. Thank you so much for the accolade and the name. Okay, so it's my pleasure to join this meeting today. Okay, I would like to on my video so that as you can see. So I'm right now at the late. I just come from one of the meeting with some of our customers. Okay, so without wasting most of our time, so I would like to go straight to the point. Let me try and see. Let me share my slide so we can put that into it. Please, I'll send a request now for me to share my slide. Right? Hello, can you please allow me to share?
Yes, try it now.
Okay. Fair enough. Okay. Can you also my screen, please?
Yes.
Hello.
Yes.
Oh, okay.
Yes, please.
Okay. Okay. So because of time, I will try try as much as possible to take it maybe from basis. Possibly if I'm going to forward too fast somehow, you can please take notes, and probably after the whole section, there's a section for question and answer. Definitely do that so that we can clear the air. So basically, we might not be able to cover the whole scenario of C&I, right, within an hour. So what we can do is to give us the basic requirements or the basic need. Even though you go to a C&I site, probably you should be able to say something about based on what we were trying to talk about today. So on this note, we are looking at the 5 principles and practice of commercial and industrial solar energy system. So going forward, I'll be using C&I. So just know that when I say C&I, I mean commercial and industrial solar energy system. Okay, I hope you are cool with that.
Yes.
Okay, fair enough. So my name is Ismail Akeem Baba today. You have one or two, a lot of introduction from my senior man there, Engineer Solomon. Thank you so much. Okay, so well, we fix C&I. So let me go with another basic introduction to C&I. So what is C&I? Or what's the essence of C&I? We are used to the residential installation and code, which I have also done several times. But precisely, the C&I aspect is designed to meet energy of business and industry. So most of the residential we do is for houses, maybe small office and so. But this one in particular, maybe some people will have told you that they are your AC. I mean, can this solar system even carry AC, basic equipment, high equipment, and so like that. So C&I is there to take care of all this storage. Okay. Please just a minute. Let me share this slide. Okay. Okay. So at this point, so introduction to C&I solar system designed to meet the energy needs of business and industries, deploy on rooftop, carport, or ground mount. So it depends on the size of the solar system you want to do. Okay. So provide energy saving, reliability, and sustainable benefits. Then we also have what is bridge the gap between the residential and utility scale system, which is what I just discussed about now. You know also that we have mini grid. So there's the C&I, there's mini grid, there's residential. So today we are not talking about mini grid, we just want to talk about C&I. They contribute to energy cost reduction and carbon emission mitigation and energy independence. Okay. So let's look at the project development stage. The first thing you are expected to do if you want to do with C&I, you need to access the site, all the technical grid, check all the available equipment. Then how viability it is. Is it financially viable? What I mean is, so most of the C&I system is unlike residential that you give a client a quote, the client will have to. But C&I mostly, the client itself cannot even fund the project. So you have a financier. And the ideal standard is that most financier, you actually see a financier that wants to finance a project that spends 100 kilowatts peak. So you look at the financial feasibility, then you check the technical aspects. So as you go into it, you probably talk more about this. So system design, financial modeling, you use tools like PPCs, Homer, Telescope, and AutoCAD. So on this one, what you are doing is you have the system. You need to test what based on what we see. You need to test. Is this viable? So you can use a PPCs. PPCs will show you if your design is okay. On the financial aspect, Homer will also help you on that. It gives you different options based on your set parameters. Okay, is this thing actually viable? What is the cost benefit compared to when I'm using grid and generator? Or if it's a place that have what's it called band A, that they used to have at least 20 to 24 hours light. So how do you reduce their bill? So Oma Pro will help you on that. Electroscope will help you to get the 3B of the whole system. If it's a system that you can find online or this on the map. Then when you come to AutoCAD. So I always say something that AutoCAD is actually underrated when it comes to design. Yeah, what we study when we are in probably undergraduate or wherever is that AutoCAD is good for all engineering work, right? But for solar, I have realized that AutoCAD can do a lot. Is this AutoCAD that we use AutoCAD for conceptual drawing? Like, is the AutoCAD that guides almost everybody? Either you are civil work, you want to do civil work, you want to do, you are solar installer. The AutoCAD, the design from AutoCAD is what you use. Step by step, AutoCAD will give you everything that you need. So I think the advice I always give people is that understand AutoCAD first. Then you now see specific area that you want to deploy. When you understand the AutoCAD, then you now go again and learn how you deploy it to fit into what you want to do, because AutoCAD is very wide. So let's proceed. Then the next thing is after you have your agreement with the client, the financial team, then your design is approved, because they have to approve your design before you now think of procurement. So you need to select the high quality and satisfied component. What does this mean? That if you go to the ranking, you will see that you have Taiwan panel. What does that mean? I'm talking about in the life of JA, Longi, there's a Jinko, so like that. But for our own projects, most of the one we have done, we have the Longi, we are using JA, and we are also using Jinko. Right? So you need to select, because of the year, the lifespan, 15 to 20 something years. You need to select an equipment that can fight the lifetime. So the quality. The other concern here on the procurement aspect is that the financier that want to give you the money, right? You have to submit the document for each of what's it called, equipment that you want to procure. The data sheet, the warranty, everything you have to submit it. So you have a procurement department that does this. So we also have subcontractor selection. Basically, it's not like a residential work that you say my company is an engineering company that wants to do it. You don't know. There's no way you do this project, except probably you want to use more than 3-5 months, you still want to be on site. There are civil area, there are structural engineer, there are electrical engineer, there are installers. So many selections. So based on your own, now your company will now, okay, where are we? Where is our best strength? Which one do we need to outsource? So you work with teams, you have with subcontractor and so like that. So there are so many.
As long as you have set the polarization to
installation. So when we are at the installation stage, we have the first thing you want to do on site. I will bring our site as an instance. We have the HSE. The HSE is what we call the cat ladder. A cat ladder is what you have that people can use to access the roof. That is the first thing. You don't just go to the roof and start stepping on the roof. Cat ladder is the first thing. You do a cat ladder, people can access the roof. You take measurement to do this and go like that. The next thing is civil work. The cat ladder, just take note that the cat ladder also has standard. Then there's a civil work. So civil work is where you're going to put your solar system, your panel, your inverter, your battery, the controller, all those ones will be in the equipment area. I have some sample here, maybe I can proceed on the training. So the installation stage, you have the earthing. So after the equipment area, the cat ladder, the next thing you want to do is you want to consider your earthing. Unlike when we do on residential, some houses, even though when you do installation, you realize that they don't even have earthing in the house. Then when you add the earthing system to your cost, they'll probably tell you that it's too expensive. Or someone tell you that, no, it's not my house. How will I do earthing for landlord? In C&I, there's something like that. If you are coming with your system, you have to protect your system. Think of the lifespan. People that drop their money want to collect their money back every month. The owner of the client also want to make sure that, yes, the agreement I have, because your financial modeling would have told them that, okay, it's like you are leasing this stuff, in the next 10 years, you take over your property. So the client that know that will take over in the next 10 years, you know, even wants you to do nothing. So if you do anyhow with them, they will also drag you. So you have separate teams that are monitoring your work as an EPC. The client itself, then the financier. So you don't want to disappoint any one of these. Okay, so the earthing is always the first point after our cat ladder and equipment area. The reason being that most of the equipment we use in our equipment area are from Huawei. If you look at Huawei, Sungrow, SMA, you realize that the system, your earthing, you must connect your earthing before you even install anything. And you must make sure your earthing are standard. So earthing also has a standard. Like power set in our home hand, we use what we call the multi-rod guarding system. The multi-rod guarding system, that whereby you use maybe 4 to 6 earth rod. It also has a standard the way you arrange it. The standard here is that when you want to do your earth and you want to use the multi-rod guarding system, if the distance between one rod to the other is 2 meters, the distance must be equal, right? Then the depth that you go must also be the same thing. What I mean is that you have, you have this bar, or what do you call it now, that have rectangular shape. At one end to the next end, it is 1 meter. The next end also should be 1 meter around. That is why you see that shape that is always the same, right? Your depth must also be the same thing as the dimension of that. That's the standard for multiple earth rods. So if you now have a multiple rod system behind this, what you do is that for PP system, your solar system alone, you earth all the solar system with the ring. The aggregate of that must have its own earth heat, separate. Your equipment area must have a separate earth system. Then your thunder arrestor. So the minimum you can have per site if you are using a multi-rod guarding system is 3. If you are using a single rod system, you have to look at your standard environment. How many single earth rod systems? So how many earth feet am I going to have? Yeah. The problem why people use single earth rod system is because it's less expensive for multiple, right? But all this earthing system, because somebody will come and test it, we also have something that we call particular stop will turn to red and your system will shut down automatically. Can you hear me?
Yeah, we can hear you, Engineer Akeem.
Okay. So then the next thing is what we call, so on the earthing, so we have the equipment layout, we have the PP layout, we have PP inverter, to ensure compliance with standards. So as we go on, we have a schematic that explains all these things further. Okay, so commissioning. So if you want to commission, you ensure that compliance with standards are all met. We also have quality assurance. You need to verify what you have done. You need to test it for some days to see that, yeah, this thing is effective. Because you need to pay immediately you, based on the agreement you have with the financier, if you say, I will finish my installation on, let's say this is October, the financier wants to start charging the client from November. So if anything goes wrong, the EPC will suffer for it. And there's always agreement also. The agreement is that I will finish this installation on 20th of this month. If you go beyond 20th of the month, there's an agreement or a document that will be signed or will be sent to you that any day that you miss, it comes with a price. So you need to factor in your installation, everything. You need to make sure your calculations are right. so that the day you propose that you hand over, it's better you hand over before the day you propose than you hand over after. Okay, so let's look at the design consideration. So site and load assessment for proper system sizing. We all know this. For residential, you probably use your meter, or you probably look at the building randomly, or you check the equipment one by one. But for C&I, there's what we call the energy logger. So you need to log the facility for a minimum of 7 days. So when you log it, you have a CSV file. From the CSV file, you get your peak load, then your average load. So with your peak load and your average load, you can do a proper sizing and design. So it's not come with two factors. How does the industry operate? Like more, they're open in the morning, close probably by 9. So this will guide you on your backup system. Because if you look at all the residential costs that you have been doing, you realize that the residential itself, like 30% of the total cost of the system is from battery. And you don't want to do that in the fair. And I remember that somebody will pay and somebody have a year of target that they are looking at. So we don't want to have unnecessary containment. What I mean by containment is that you even don't want your solar to produce, and it's not like for residential, when you produce sometimes and the load in the house is less than what you produce and the battery is full, there's no way you want to use it. It's waste. Right? For C&I, people are there to read this and show you your containment every year. So if you have too much containment, that means you over design. It is wrong. So that is why when you are using your Homer, there is what they call sensitivity in a Homer. You need to set that. When you set it, it gives you different options. Like, okay, this facility, if I design 200 kilowatts, 300 kilowatts, like you can do it on option of 50-50, 200, 250, 300, they're probably 350. So when you set all your parameters, and at the end of it, someone will give you different options based on that you set, and it will give you the performance ratio, your probably containment, the loss you'll be having on the system. So it gives you percentage, or you give you the performance ratio and so like that. So the sizing is very, very, very important on this system. So I think maybe the time we need to factor in our time and move on. So the next thing is a roof structural analysis. So there are some facilities that we have been actually that we realize that when you get in areas that is wood that they used to do their roof. Basically, almost all the facilities that we have visited, and we realize that they use what's it called, plank or wood. Outrightly, we reject it. Outrightly, because the strength, there are the people, we have another department. These are the people that do with structure. These are civil guys and people like that. So they need to do a structural analysis. You need to submit the structural analysis to the engineer for them to see that, yes, this group can actually take this system that I want to bring. The weight of each of your panel, one panel, if you use DIMCO, I think our longi that we use is 555 for the first 10 side that we did. 555. That longi is 27 kg. So 27 kg multiplied by the total number of panels you want to use. What are the walkway? The walkway, the lifeline, the MC4, the walkway, the lifeline, the mid clamp, the end clamp, all those things you need to factor in. What is their weight? What is the weight of the roof? Can the roof support this weight I'm bringing? Because this project is not a project of 1 year, 2 years, 3 years. So the roof structural analysis is, these guys must say yes before you proceed. I will give you a sample of one of our sites that probably one of our sites in there, one of the more that we want to try to run. When we realize that it's roof, there are two conditions that was given to the chairman. One is this roof will be reinforced, and every 3 years, you need to come back and reinforce this roof if you want to use wood. But if you want to return it to set coal line, which is the iron pipe and coal like that, it will cost a so amount. When you factor in those prices, then the gentleman say, no, I would rather go for carport. And he consider the cost of carport as well. So these are things that you need to check very well, make sure, yes, this thing is actually good. And in the roof structure analysis, not something that you go to the roof and go. I think that is what most of our guys do in the residential work. They just go to the roof and bounce on it and say, this roof is strong. No, it's not done that way. So we have optimized tilt and absolute angle. So if you are doing your PPCs, you will see that when you set, there's a portion there, the tilt angle side, right? You want to see what is the slope of the roof, right? For south-facing system, which we in Nigeria, right? I used to set between 10 and 15. As you are setting it on the PPC, you see that when that arrow comes to 0, for those of you that have used PPC before, so once you set it to that, yes, it's 7. So you can get this tilt angle. You now look at it that, okay, this building is, I'm not the one that built it. How do I know this, what's it called? The tilt angle on the slope. It's very easy. That's why I put this on a clear. Sorry. This particular tools, you can get it from your Play Store, inclinometer. So once you get down towards the edge of it, you just place it. If you download it, or you just place your phone there, it will tell you the scope of it. You understand? So you can use that to carry out your design and to make your design more easier. So select efficient components and reliable. In fact, I think we have talked about this, but when I go front again, I think I'll see. So ensure structural and electrical safety compliance. In in C&I, especially when you have your financier from outside Nigeria, HSE is as important as the solution you want to do. If there is a snag from HSE team, your installation will be stopped. You have to take care of it. In fact, HSE team can stop your work indefinitely. Like, you must meet up with the standard, the environmental impact, the safety of the people that want to work on site. That is why when you go to our construction facility, you realize that for you to access the roof, you have the path ladder, you have the scaffold. During construction, a scaffold is used to access the roof. But in case of emergency, we don't want everybody to go through scaffold. We have a path ladder. In fact, there are some facilities that they will now even tell you that once you have a distance that is more than 30 meters, you must have another, what's it called, cat ladder, because somebody that is 30 meters far away to where you have the cat ladder is not expected to start running from there in case of emergency and start running to the other side. So that's why you must have another cat ladder nearby. So this, as I said earlier, the cat ladder also have a standard from beginning to the top. So safety in our team, we have the HSE staff, we have contractors. So for you to know how important it is. And every financial team also have their safety team. And you must submit all their requirements. For those of us that understand the SDG, SDG 7 is all about energy. So it speaks more about it. So if you have at our lesson, you can read more about SDG 7. Yes, 7 is for energy. So at this point, this is CP system layout. If you look at this, I was saying something about AutoCAD the other time. This in particular, can anybody guess what kind of software do you use to do this? Hello?
AutoCAD.
Oh, God bless you. So this is AutoCAD. So if you look at this, we have the walkway here. I call it major walkway. If you check again, there's another major walkway here. Then we now have minor walkway after two panel. So in case of maintenance, if you want to maintain this panel, you have access to the roof. You can easily move around the roof without any constraint. And the HSE team will be here with you looking at it. Because a single incident can have more than 5 years impact on the company. So nobody wants to get that. I don't want to jeopardize your name. Okay, so this is a people system. This is a layout. Now, if you look at this on our residential, you now say, okay, look at this, all this place. All this place. I suppose we'll have put some panel, This is a building that has a parapet wall in the front. The height of the parapet wall, whatever it is, you need to calculate where is the parapet wall coming from. As a Nigerian, right, we have north, south, so we want our panel to face south. That means the sun rise from east and set from west. Any parapet wall or anything that you have that you know that can cause a shading on this panel, especially from the east and the west, you need to take care of it. You need to do that calculation to make sure that it doesn't happen. Because in the morning, as the sun is setting from the east, the shadow goes towards the west. And in the evening, from the maybe around 4 or 3:30 in the evening, it goes towards. So that means if this is my east and I have a parapet wall, so if there's in the morning from probably 8 to 10 or 11, I will have a shadow. If this thing is higher and I don't give this clearance, I'll have a shadow that will cover some of the panel here. And in the evening, I'll have a shadow that will cover some of this panel here. I want to avoid that by all means. So now, there are so many concerns you now have here. The roof is not big, then there's no space for carport. So you want to manage the space. So I'll face a scenario whereby they now say, okay, we use optimizer. So when we look at the cost of the optimizer, then we look at what we want to do. The next thing we are advising is that please forget about the optimizer. The optimizer will have lesser impact and it will be waste of resources for you to use optimizer. Instead, let's avoid this area and we did, and at the end, what we are generating is more reasonable and more important than when you even use optimizer. So basically, this is this. We have, so for this type now, this is just a PV layout. You need to dimension this way. Because the financier that you want to submit this to, let me give an instance of probably one of our financiers. When you submit your document to them, they have a team in Nigeria, they have their team in Kenya, qualified, satisfied engineer, but they still have 2 consultants that will review your documents. If anything goes wrong from the consultant aspect, you have to go back. And the consultant, they don't even know where the roof is. They don't even know where the facility. The only thing is they can Google it online and just look at your layout and probably give you what they think is wrong on your drawing or your design. So we have so many issues like that. So you need to make sure that, okay, what I'm doing, if I'm not there, right, the person that wants to open this document should be able to speak and say, yes, this is what this guy is talking about. Okay. So this is one of our sites. We have I just talk about the HSA. You will see that we have a walkway. This is our walkway. And this is the way we have the walkway ran is open. So that if I want, maybe somebody wants to visit our site for maintenance reason, you see that there's a walkway. In the walkway along the line, we also have what we call the lifeline. Because you can see when I'm on the roof, I have a lifeline, I have a body harness. I have to anchor this body harness to something. So which is the lifeline? The lifeline is arranged along the walkway. If you look to my right, from here now, if you look to my right, you will see a gathering around the whole roof. Because you don't want to leave anything and you don't want to hear story that caused that. And when I was doing my maintenance, I was here, I don't know that nothing was my back. So we have this gathering. Anywhere that we don't have a parapet wall, there's always a guardrail. And the minimum standard we do for our guardrail is 1.2 meters. The reason being that myself, my height is 1.7. If I stand so close to where I have the guardrail, I feel the guardrail should be able to cover more than half of me, right? In case of anything, that be able to guide myself. Or what we are looking at is to make sure that everybody that comes to this site are safer. When you leave your house in the morning, then they say goodbye, daddy. They want to say welcome, daddy. You understand? And that same face, that smiling face you leave in the house, you want to go back and meet. And you don't want to go to side and say, it's that access side or somebody's side that this person went and probably this happened. So we'll try our best, all necessary protection that we need to do to make sure they are in place. And anytime you go to site, you only go with the HSC because as a woman or probably as an engineer, sometimes we feel like I've been going to this all the time. So the HSC are always there for you to say, bro, engineer, please. So the HSC might be small, it might even be a lower ranking person in your company, but it can stop you from working and it can even stop you from going to the your safety boots, your helmet, and so like that. So everything needs to be top notch. So this is the sample of our walkway. I was just talking about walkway. Hello, someone is okay. So let's proceed. So this is our lifeline, as you can see. So you can only anchor your your body harness. You can anchor your body harness on this lifeline. This is our walkway. So this bus pipe is just for us to make sure that we are able to, the roof also have trusses to trusses. The truss from here to here. So we need to put this base for this walkway to stand. Okay. All these ones, they are even locally, these are locally manufactured or locally fabricated. We have the one that are foreign also, which we have some of them on our site as well. So we want to see C&I Solar System. What are the active components that we have on site? There are some components that, basically there's no way they are visible, everybody can see into any site. So one of them, I want to start from the top. We have the mounting rail structure, MMS. This mounting rail structure, at this point, I want to try to sit in something. The mounting rail structure that we have, we have different quality, and this is why quality of material comes to play. If you use a mounting rail system, you want to etch your panel. You remember that your panel and the mounting need to, you want to place your panel on top of your rail. That mounting rail, if you etch it and it's not connected to the panel, there's a problem. So your mounting rail structure, the MMS, must be standard, must be quality. You don't use aluminum rail, no, for C&I project. Remember, there's no way that will fly. In fact, even the rails, I know some of us will know genus there and so like that. So the kind of rail, like the type of genus, there are still some that are still not to standard. So we also have the clamp, the air foot, the main clamp, and the air clamp. Most of the residential work we do is just main clamp and air clamp. And I'm not talking about the main clamp and air clamp that you buy, I think the one of 300 for no. You know the kind of the standard main clamp that you can use. So we have ray class. I say ray class PP ethi cable. We have the whip, we have the clips. So on this part, right, we have experience whereby you look at the ray that okay, the panel will be on the ray. If I do the earthing for all the ray, link the ray together, automatically my PP is on top of the ray. So it means that my PP is connected to the ray, then the earthing is too. So along the line where we are now doing some testing and code, we now realize that most of these rays and the panel, they are highly coated. If this is when the issue of earth width now come into place. The earth width have 3 or 4 mouths, right? And it has a hole in the middle. So where you put your main clamp in between 2 panels, you need to have earth width. That earth width, there's an iron, sharp iron, 2 on this end, 2 on the other end. That can, but once you are joining your panel together, it will clip it together. Once you clip it together, if it tests the continuity between the panel and the ray, it will continue. But if you don't use that earth tube and you earth the ray alone, if you test continuity between the ray to ray, where you put your earth on the first one and the second one, you will have continuity. But when you test the panel and the ray, there won't be continuity. Therefore, you are not earthing the panel. So the purpose of earthing there has been defeated if there's no earth tube. And the earth tube is just something of, just like a blade. So you can look at it online and see what earth tube is all about. So we have the solar module that generates the DC. We all know this. But the most important is for C&I, we don't buy used panel, we don't buy second hand, and you must go with Taiwan. In fact, some financial will even tell you specifically this is the type of panel that we have. I mean, we want. If you use anything contrary to that, nobody will accept it. And sometimes they'll even outsource the panel after they will outsource it to another company to bring it for you because they don't want to compromise at all. We have the weather station. So the weather station, we always put this on the roof where we have the panel. All it does is to monitor the irradiance. You will all know that it's not the intensity or the sun is that generates that gives us what we need or that makes solar to generate very well. What we need is the irradiance. What are the irradiance on that environment? The irradiance, the more irradiance you have, the more the good performance ratio you have. So if you have a good irradiance, your performance ratio will be good. Once the irradiance is low, the performance ratio will be low. So we have this weather station. It's always connected with the communication cable from here and from the equipment area because we also have a system that monitors the whole system. We have the PV inverter convert DC to AC. So I think some people call this steam inverter, PV inverter. I think there's other name. So basically, there's this inverter that there's an inverter that needs a reference voltage to work. It's what we call the PV inverter. So what the PV inverter does is all the stringing we have from the solar system. When you are breaking it down, we connect it to it take the DC source. We connect it to the PV inverter. The output of PV inverter is an AC because the system we are looking at mostly they are always grid type. They are AC coupled. You want AC to go to the whole system. So what you need that's going to your controller is always AC. The first one is from grid, is AC. The second one is from your solar. But remember your solar produce DC, so that's why you need a split inverter. So the split inverter will convert the DC to AC. Right? So there are so many things that you need to understand about the split inverter also. It's very from manufacturer to manufacturer. But there is a rule that guides almost everybody. There's what we call the DC to AC ratio. Your DC to AC ratio, 1.2 is good. Don't go beyond. Yeah, some people go 1.31, but I always advise you don't go beyond 1.2. The essence is that the more you go, the more creep you have. Once your PV is producing more than what the PV inverter can take, you just keep it for and you are just starting a waste. So 1.2 DC to AC ratio is fine. What I mean by DC to AC ratio is that if your solar system is 300 kilowatts, 300 kilowatts peak, your PV inverter minimum, we have different sizes of this PV inverter. We have the one of 50 kilowatts, they even have smaller ones, but for who are we have the one of 50, we have 100, we have 150. But when you have a system that is less than 1 megawatt, or let's say less than 500, please just go with 50 kilowatts. Because if I have a system of let's say 400 kilowatts, I not say okay, because I want to reduce the space. Let me use 4 PV inverter 100 kilowatts. That is 4, and that is 400. If you have 400, what about anything happen to one of these inverter? Probably normally it's a system can shut down at any time. Anything can happen. So that means at a time, once that system shuts down, you are losing the 100 kilowatts. So the idea thing is start from small if your system is not too big. For who are we? They have 150, they have 100, they have 50. So back to what we are saying, that let's assume I have 300 kilowatts on site. How many PV inverter did I need? Because I want my AC, DC to AC ratio to support what? 1.2. So if you do 300 divided by 250, it will give you exactly 1.2. So if I say 250, so that means if I'm using a feed-in factor of 50 kilowatts, for me to have 250, that means I need 5. So if you are dealing with 300 kilowatt system and you have feed-in factor of 50 kilowatts, that means you need 5 of it. So that rule, for you to maintain that rule for 1.2, DC to AC ratio of 1.2. I hope you understand this. So aside that, also, if you are using a feed-in factor, depending on the brand, you still need to talk to the manufacturer. There's something we call parasitic core. You need a parasitic core. If not, they will tell you that this feed-in inverter, it has an MPPT. The voltage of the MPPT of this inverter, let's assume is 1000. If you now size your system based on that 1000, it means that I can put 19 panels in a string. If you put that 19 panel in a string, you will realize that what you are generating, you can't generate up to the maximum, or you are not maximizing that particular peak inverter. Because on the characteristic core, the characteristic core will now be the one to tell you that if you use your panel, if you maintain between this social footage to this social footage, you will have a maximum output on the core. At 900, by that time, or at 800, the PP inverter production will have been dropping. So you need to understand what the characteristic core of that system is. And that will help you that will help you a lot to understand how many panels do I need per string. Okay, so I talk about PP inverter, converter. Oh, this is tautology. So we have PP inverter combiner panel. So in a system whereby you have a PP inverter of probably, like the example we give, let's maintain the example we give of 300 kilowatt system. We say we will need a PP inverter of 5. So if you need a PP inverter of 5, each of these PP inverter to the controller says no. So instead of that, what we do is that there's what we call a PP combiner panel. The PP combiner panel is now the one that will combine all the PP inverters together. Then the aggregate from that PP combiner panel will now go to your AC coupled system. This is your controller. Okay, so the next thing we have the BESS, battery energy system solution. This one, the Huawei 200, I call it 200, it's 200 kilowatt hour inside the battery, inside the base. It is like a cabinet. The battery inside is 200 kilowatt hour. The 200 kilowatt hour system base have an inverter, which some people call it battery inverter. Some people call it battery inverter. Some people call it PCS, right? If you look at the 200 for Huawei, they have connected everything for you internally. What you need is your output, which is light, neutral, red, yellow, and blue, and your what? Neutral and earthing. Mind you, for 200 for Huawei, it doesn't have a neutral. Therefore, you need to introduce a transformer. I will give this instead of like when you are running from PSN or maybe from the substation down to your transformer, you realize that it's always 3 cables. So the 3 cable will not get to the transformer because they want to supply your house. Your house they want to supply doesn't need a neutral. So they will not have a step-down transformer. A step-down transformer to what? To introduce the neutral to you and to step down the voltage from where it's coming from, probably from 11 kilowatt, 11 kVA, to probably 415, the 3 phase that you need in the house. It's the same thing of what we are talking about here. The best doesn't, for 200 precisely, doesn't have, I'm referring to Huawei products. The 200 does not have a neutral. So you need to introduce what we call the isolation transformer. What isolation transformer does is that it introduces a neutral for you, and it also protects your system because it's a two-way force. The grid that will come into your coma to your base is also passing through the transformer. But the transformer doesn't step up and it doesn't step down. Isolation transformer is different to step up or step down transformer. We can probably in our lesser time, or if you have any other question, probably after the class, also better to me. So we have the cable and the connector transmitting power safely. So there are so many sizes of cable. For the PV inverter, based on the size of PV inverter, you need to size the size of cable that go from your PV inverter to the PV combiner panel. Then the aggregate of the PV combiner panel that is going to the coma or probably your whichever controller you want to use, you also the square size. You size your best also to make sure that what is going to your what's it called this AC couple system are well sized. We have the monitoring. So for Huawei, we have what we call the SAPI, Smart Area Control Units. And we have what we call the controller. The control. The control itself, we have so many of them. Depends on what your company wants, or depends on your brand. Like if I want to use, sometimes Huawei recommend that, this system, this controller works well with our system. You understand? And because you don't want to gamble, so there's no point, just go with it. The difference in their price may not be that much. So on the control, we have what we call the Dayon. We have this Dayon, we have Dayon cabinet, we have Pomap, we have Elon, we have a combi, we have SMA also have their own. So there are so many of them. Depends on what the manufacturer probably agree or propose, or probably based on what you have used, so that you have a seamless system. Like you don't want a system whereby the same structure you're not looking for what is not lost. Okay, so this is one of our. I was talking about the PV inverter the other time. This has the PV inverter, the one from Huawei. This particular one is from Huawei. This is PV inverter. This is PV inverter. We have PV inverter here. Here we have PV inverter. Then this is the PV combiner panel. Then this is the circuit. Then this is the Dayon cabinet or coma. So it depends on your manufacturer or depends on the product you want to use. They might recommend for you or the one you have used before that I think this work well for you. Okay. So we also have, this is 200 kilowatt hour, the one I got 200 for best. This is the 200 kilowatt for best. So if you look at this very well, on this side, this is a controller. This is a PCS.
Energy system storage.
Okay, so then I will try to see how we can break this down. So when you are not using your system, look at this layout. This is more like the SLD. I just want to see how we can just make everything we have talked this morning, everything that are encompassed in this SLD. This SLD explains everything we have been talking this morning. So here we start for PV. If you look at this system, is well labeled. I have 280 units of PV system here with the brand stated specifically here. The cable that we use to carry out from to the stinging, to take our stinging from here to the PV inverter is 6 mm. The same thing, we have the PV inverter. For this system, we use how many PV inverter? We use 3. So you yourself can also do yourself a good by looking at it based on what I just explained. I said something about 300. This is 280 panel. If this is 280 panel, this is how many kilowatts. If you get the kilowatts, you can easily calculate how many PV inverter you need for this system based on what the analysis I just did. Okay, so we also have, we also have this particular guy. This is a PV combiner panel. It's smaller here. That means the aggregate of this and go to the PV combiner panel. We also have a meter here. Because the essence is that your financier, this is the way they charge, right? Financier want to charge PVs. You can't, the cost for PV and the cost of battery are not this. So there's different deduction, there's different charges. So that has a different, another thing entirely. So the output of this guy come to this Dayon cabinet. Either Dayon cabinet, Elom, SMA, it depends on the controller you want to use. This controller is the brain box of the whole system, right? It will be the one to determine, okay, this is the load in the facility. This is what the solar is producing. Okay, if this the load is always priority, we take this away from the load. Do we have anything left? If it's, we have something, go and charge the battery. If it's not enough, based on your settings, right? What is the priority? Is it solar, grid, battery, and gen, or PV, battery, grid, and gen? I will advise you, or probably based on what one of the chairman said, that since I've bought the battery, there's no point for grid to come out before the battery. So in the ranking, it will now be PV, battery, grid, and generator. But you know that the cost of grid is less than the cost of battery. But he has paid for it already. So there's no point for you keeping it with your other. So that's that on that. So the output of this guy comes here, comes to the coma. We also have the grid from the NEPA pole to the transformer to the isolator, then to also this. All these are what? AC system, AC output. This guy doesn't take DC. The controller doesn't take DC. The same thing go with this, guys. These are the BSS, the energy storage system. The energy storage system also, the output of this guy, because this is a DC from the battery, this guy will convert the DC to AC. Then the output of this guy also goes to this guy, which is the controller. So the controller is a controller that will now supply the aggregate of this guy, now goes to this ATS. Then the one from generator also goes to this ATS. So it's the ATS that will now supply the load. So, but the primary is always this guy, except if any of these three sources, 1, 2, 3, are not available, before the generator will come in. This one, if you look at it, is totally different to other people's design. This is peculiar to us. This is peculiar to the company I work with, right? The reason is this. I want to cut costs on diesel, right? If my battery is low and I'm using this same generator to charge my battery, the effect on the generator will be high. Then the cost of diesel will also be high. Okay, I don't want to have any business with this battery as far as this my system is concerned. Except if one of these, 1, 2, 3, are not available before this generator will come. And when this generator comes here, I only want the generator to power the load alone. It must not charge my system. So every company you have reason for your design, and you should be able to explain it based on what you think is right, or probably what you agree with the client. So we also have some other system which is different to this, that you incorporate it with generator. The generator will be running, then your system also will be running. But you must size it in such a way that it will meet the standard requirements of the generator, maybe base load of 30%. In whichever way, but this is what we are doing, and this is what we think works best. Though this one is more, in terms of cost, this is more expensive compared to the cost of the battery. Wherever you have a battery, you should always expect things like this. Okay, so after the whole of this, we now have the operation and maintenance, because it's another thing entirely. After the construction phase, there must be another phase for O&M. The O&M is another agreement entirely, because if you go to your PPCs, you remember that you set what we call the soiling percentage. So that soiling, that stuff, the dirty and co like that, that you set on your PPCs, it's either you maintain it or you allow it to get higher. And once you get higher, your performance will be low. So you need to take the routine inspection and preventive maintenance, the real-time monitoring. So for who are we? We have what they call the fusion solar. The fusion solar is what they use. You can monitor the system anywhere you have. So even the weather station, the irradiance, if the system shuts down, you will know. If anything happens to the system, you will know. But for who are we specifically, they use fusion solar. Every other manufacturer have their own real-time monitoring software. But for who are we, they use fusion solar. We have regular cleaning to minimize soil loss. For this one, I think once in a month, at least once in a month. Then we have early fault detection and rapid troubleshooting. We have monitoring performance ratio for reliability. If you don't carry out your maintenance very well, your performance ratio will drop. And for C&I, with your client, you must sign a particular percent for your PR. Okay, my PPCs, your OMA, this is what you give, that you will be having a PR of 75%. Once this PR is dropped, it will also affect your pay. So test for PPU hotspot with thermal imager. So there is a software that you can use to test for hotspots on your panel. Maybe during installation, maintenance here and there and so. Then, mind you, if your system is not well maintained also, it can also cause an hotspot. So there's software, there's an, what's it called? A tool that you can use. I think Fluke have it. I think I have some for it. Okay, this is the one from Fluke. It's a thermal imager. Once you just stand on the roof, as if you want to probably do a kiddo as you are moving around. If there's anyone that have hotspot, this particular tool will capture it. Then you can easily detect it and replace it as need. All right. So this is the way we carry out our maintenance. So maintenance have so many ways you can do it, but to make it easier for you, you don't want to use more on the maintenance, on the panel. How many panels you want to use more? So the more you carry more people on the roof, you are adding more weight to the structure, right? And remember, what most of the things we have in Nigeria, the roof and other things like that, they are not that strong when you consider the standard. So with this, I think you can cover fast, you can do more cleaning than you using a mop. I think they will still have some the robot one that you can use and control to clean the panel for you. Then it's also of note, that you don't want to do your maintenance probably during the day, like maybe between 12, 1, 2, 3. The panel are hot already. The best is to do it early in the morning or probably in the evening. So this is, if you look at this is the Christmas solar that I told you about. This is the screen, this is the display. This is the screen. You can monitor the whole system. You see, if you check to this side, you realize that these are the list of sites we have. You can click on any one of them to monitor the performance of all the systems. How they're sharing, how if there's any shutdown. In fact, there is even a software that you can start the system from your side if the system shut down from site, you are not there. So I think this was okay. So we want to look at the economy and policy consideration. So this one, you need to evaluate your CapEx, your OpEx, and your payback period. Very, very important. All this one, even though you as an EPC, if you don't have this one, even the financer will do this because they don't want to make loss. So you also need to consider your LCOE, the levelized cost of energy, for lifetime cost comparison. So if you do your if not for the country that we have, for every other country, right, in the same environment, right, there's always the way you do this. LCOE is very, very important in the sense that if I want to give you a solar system and you have a grid, I need to look at the environment. What kind of solution is best for this area? You don't just want to deploy in the area that is far away for substation, for distribution station or so. You don't want to run a long pole because you want to supply that area. So there's always this levelized cost of energy. You can do it for your panel, you can do it for your battery, your inverter, and everything, because you need to consider a lot of factors on the levelized cost of energy. So now we now look at some facility that have
levelized, not levelized, levelized.
Yeah, okay. I think the right topic. We'll update that later. So what we are saying now is that if I have a facility that has that is in band A, and you want to bring this system, band A already, you know that fine. With grid, they are okay, right? Aside from when we have a shutdown from our, let's assume there's no shutdown. What is the benefit of me using solar when I have a band A? So in UAW system of the COMAC or beyond that we use, there's a setting that you can do that during the day. Even I think there are some smaller inverter that does this as well. During the day, I don't want my grid to come in. Even though the system, the battery is, as long as the battery is within social percentage, right? I don't want grid to come in at all. So for instance, one of the settings we did is that during the day, we don't want to see grid, except if the battery is less than 30%. The grid will come in, it will not charge the system. It will only support the available PV to supply the building. That is one. Also, in the night, if the battery is low, because we realize that the client will need to open early in the morning, and we don't want it to come early in the morning, there's no grid and start running the generator, right? So in the night, if the battery is low, the grid should be able to charge the battery, but the battery should not be charged more than 50%. It's just a personal decision from our own end. So your company of your own, you can decide on probably what you need, but this is the way you can reduce the cost on the grid and on the diesel. Okay, so the next meeting, feed-in tariff, though this is not practical in Nigeria right now, but basically with this one, if this essentially works, it will make a lot of sense because in some of our facilities, we realize that there are roofs that can take in more than what we install. But because they don't want to waste, we don't want unnecessary containment, we decide not to go with it. We decide to do basically on what the facility requires. Right? So comply with local grid code and energy policies. All these ones are very, very important. Very, very important. We have financing model, papers, so like that. So that's just the economic policy and the constitution. So in conclusion, I would say that C&I Solar System offers a sustainable and cost-effective solution. Success depends on design optimization. You realize that the engineering team, you must have a sound engineering team before you can pull up all this stuff we are talking about. Continuing innovation and policy support drive adoption. So what I mean here is that if you look at initially when we install this system, most of this logic that we set right now, we don't have it then. But when you are looking at the way your system works, at the longer we want to see what can we do to have more benefit from this system. So like that, we keep innovating, thinking of, okay, what are the other options that we have? What can we be doing that make it different to others? Or that all in essence just to reduce the cost and to make sure we maximize profit. So at the end of it all, I would say that, and this is all I always say for even for residential as well, that design is more like 90% of the whole system. If your design is wrong, the system will be wrong. Thank you for your attention.
Wow, thank you so much, Engineer Ismail. Thank you for that wonderful and insightful presentation. I want to say very big kudos to you. And it's always a great one, when we have you come around. And we say thank you and well done to what you're doing in the industry. Yes, and again, also want to thank you for your time. You really took your time to make sure that you explained every important aspect of the C&I solar system. So once again, kudos to you and well done. Yes, so this is the part for the question and answer section, right? I'm very sure that we must have had jotters filled up or we have our questions already written down, right? So this is the one moment, the time. If you have any questions, you can unmute yourself and then ask Engineer Akeem, or you can as well also type it on the chat bar, and then I will just go ahead and read out your question so that Engineer Hakim can attend to all of our questions. And again, also in that note, before we end the webinar for today, I'll be sharing the link to Engineer Hakim's Telegram page, so we can always LinkedIn page. Sorry, I will share his LinkedIn page, the link to that, so you can always follow him, connect with him, so that we can learn and then engage with him to get more from him, his wide experience in the industry. So I think I'm seeing a couple of messages popping up on the chat bar. So yeah, Abubakar, you want to ask? Okay. So we have thank you,
Hello,
Engineer.
Engineer Solomon.
Yes.
Hello, Engineer Solomon. My own is not
Yes,
a
Abubakar.
question, but my own is not a question, but a request.
Okay.
I am in the field and I missed some part of the section. So please, if possible, we need the recording of the section so that we will go back through it. Thank you very much.
Thank you, Engineer Abubakar. Yes,
Thank
the
you.
section is being recorded, and then the link to that also we posted on the alumni group for the RETI YouTube page. So we can always go there, listen to it, and then have the video of this section there on the RETI YouTube page. So the link will be
Thank you so
posted.
much, Engineer Solomon.
So for those asking for the presentation, the slides, I don't know if Engineer Akeem will want to share his slide, and like I already answered to Engineer Abubakar, the section is being recorded and it will be posted across our platform, YouTube, and then also on LinkedIn. So you can always go to the RETI page and then get the copy of this recorded version of the section. We have another question here. I wanted to understand. So Engineer Hakim, we have a question here. He said, I want to understand on the solar system diagram for designs. I saw the BESS diagram and the line diagram. Should I do both for a client? Engineer Hakim, there's a question for you.
Oh, okay. I think I need to understand that question clearly. Like, it's so, I'm coming. Like, if for an SLB and PP stop, can the person speak so that I can get the question ready? Yeah. Hello, can you hear me?
Yes, Tatenda, can you unmute to ask the question so that Engineer Hakim can get you clear? Okay.
Okay. I was saying that I saw the design layers. I don't know how I'm going to say it, but I saw the diagrams for the solar system, from the solar panels, battery, and everything. So I was asking that, do I have to design for each and every project to put my solar system, and which one is recommended? Because I think I saw the base diagram too, and also the line diagram. And also, are there applications I have to use? For example, let's say I have to draw something recommended AutoCAD and everything. Is there any application I have to do those?
Okay.
Engineer, yeah.
Okay. Thank you so much. Okay. So for system layout like this, right, especially for C&I, it's not even only these two layouts that you see that you need to supply to your precisely the financier, right? Most at the end of it, the client majorly don't need it. If you are fortunate enough or you are lucky enough, right, you will have a client that want to pay for this system. That means there's no need for finance, right? So, but for your team to work, you just realize when you have an MEP, you want to know your electrical service design, that you want to know how many blocks should be this year. You need to do this AutoCAD to factor your equipment area, your PV layout, where your earthing will be. So on this note, because I shared these two drawings, I will probably just go through a complete drawing for you to see just one of our drawings. Some, in fact, there are some that we have more than 20 something pages, and each of them have what they talk about. So just permit me to quickly do that. That particular side that I just can see different. Okay. The layout that you saw just now. So this is peculiar to us, and this is our own concept. So this is the front page. This is the active component. This is the SID that you saw. This SID is what I assume that if I give this to a layman, like a layman, at least you should be able to say one of things based on the direction, the way this flow moves. Okay, this one, they will give me this component, they will give me this component. So this SID is basically for probably the client, just for him to have idea. But when it becomes technical, we also have the one that goes behind this. So we also have this. This is the roof itself, the way the environment looks like. Then this is when I do my design, I superimpose it on the roof. Then this is now the one I added to the slide. Then this one is the stringing. I want to show you how I string the whole system. Where is the key inverter one, which one is the key inverter two. Now, if you look at this also, you realize that I indicate so many things here. The cap ladder, the scissor split, the scaffolding. So the scaffold, the cap ladder, and the scissor split. Because on this kind of job, you are not expected to use rope to lift your panel to the roof, except if you want to put the life of people that are working on site in danger. So you need a scissor split. So we also have what we call the major. If you look at the walkway, the one you saw, this is the cable tray, this is the walkway, this is the lifeline, like that. So there are so many things you need to share with the client. This is a single layout. I want to indicate that one PV inverter, this is the number of PV. Per thing is so number. Okay, this is the total number of things that is going to this PV inverter. So you need to indicate that this one also is there. So we also have this one that explains what's the name, the earthing layer. Where are we having the earthing? So many of them actually. Then we have the maintenance layer. After the work, right? You want to maintain this facility. Where are you getting your water from? So this is our equipment area. This is now the equipment layout. Like, okay, what is the dimension that you need for you to place your equipment? Each of these equipment have their standard. What is the clearance it must have between this equipment and this equipment? What is the height of your building above the equipment? So there are so many things we need to pull out for you to send to the client. This is a single line diagram, normal SLD that we all used to. So this is the best, this is the PCS, this is the PCS, This is the grid. This is the one coming from grid. This one and the third pitch that I told you about, they are almost of the same category, but for technical person, if I submit this, you should be able to understand it. But for them, I will submit the other one. There's also another one that explains the way the stringing are also arranged, like the PP stringing, the way they are arranged. I can easily show you that. I think I have one of it here. This is the communication connection. This is also, look at it. I have 3 PP inverter here. Each of these PP inverter, look at the way they are connected. That means this particular, I have 1, 2, 3. They have 7 strings. And each of the strings is 14 panels. And these are also calculated based on the parasitic curve I just explained the other time. So for the drawing, actually, it depends on the kind of clients they are dealing with. But for your team as well to work, right, you need a drawing, a conceptual drawing that will explain what you want them to do, which you can do with AutoCAD. AutoCAD is the best software that can do that for you. But for PPCs, I've told you what PPC does, what Oma does, what Telescope does. But there's no way you run away from AutoCAD, because it's from AutoCAD you can clearly explain and pinpoint where exactly you want this to be, where you want this to be. I don't know if that answers your question. Thank you.
Thank you, Engineer Hakeem. She has already commented on the group that is clear to her now. So we have another question from Wisdom. It says, my question is regarding earthing, right? Is the DC side solar panels connected to the same earth rod that houses the AC side of the system? Said, my question is regarding earthing. Is the DC side solar panels connected to the same earth rod that houses the AC side of the system? Did you get that, Engineer Hakeem?
Yeah, very clear. No, it's not. You run an earth kit, separate earth kit for your PV. DC earthing is different to AC earthing. Thunder arrestor earthing is also different, like LA, lighting arrestor. It's also good for you to know that your AC cable and your DC cable must not pass through the same thing. So it depends on the size of your system. Your earthing system that you probably do, that's why I give you different, we have different type of earthing system, but I give you based on the industry. I've been with Paras, the owners energy, the Indians and co like that. The way they do their earthing, they use the single earth rod grounding system. For power set, we use multi-rod grounding system. So you need to look at the pros and cons of this to see the one that will fit your system. If you are using a single earth rod, you know that you have so many here. It will not be the one that will not come up with this 6 inches or 4 inches of pipe. But for multi-rod, a single multi-rod can take care of the whole DC system. But your PV, this is your DC, must have its earthing system. Your AC, that means your equipment area, must have a separate earthing system. Your LE must have a separate earthing system. In fact, I'm just trying to, part of the innovation and thinking ahead as well is that, most of the roof that we have, sometimes you have a roof that some side face south, some side face north. In your stringing, right, when you are stringing your system, it is not advisable for you to string a fitting inverter on the north side with the fitting inverter on the south. You are doing a smart. So the standard is all the PV on the north to form a string. In a string, it's not advisable to have what? North and south panel on the same string. I can have a string from north and a string from south in a string in a PV inverter, but I cannot have panel on the north and on the south on the single string. The same thing So we are now looking at the earthing system whereby if we have a larger system, we'll design in such a way that whereby we have our node that will have its earthing pit or separate, that will have its earthing pit, and the one on the node have its separate earthing pit. But as I said, if you have a larger system, I don't know if that answers your question.
Thank you, Engineer Hakim. I'm sure, Wisdom, you heard that. So lastly, we have a question from David. He said my question. He said the question now is: you mentioned AutoCAD for layout drawings. How is that closely integrated with tools like PVSys or Hammer in a real project workflow? And then, secondly, can I use Python in place of Hammer for a system design? Let me take that again.
Okay.
Now you mentioned AutoCAD for layout drawings. How is that closely integrated with tools like PVSys or Hammer in a real project workflow? Secondly, can I use Python in place of Hammer for system design? That's a question from David.
Okay, thank you, Ricky. Okay, so if you follow closely with my analysis, what I said is that we have Homer, we have PTC, we have Indusrial, we have AutoCAD. These four software have different inputs. Your Indusrial come with a 3D. The AutoCAD is trained you with a 2D. Your PPC is for you to design. In fact, for you to do your PPC, you need to know that you also need to understand your design, the basic design, probably with your Excel or your manual calculation, but Excel is better. Then you now place it on your PPC. If you want to do your shading analysis on PPCs, you need a SketchUp that you can import from SketchUp. So these PPCs do a 2D layout for you. Fine, there's where you can do 3D from PPCs, which is not that easy, right? The same thing from OMA. OMA is better in financial modeling. Your PPCs is good in your design. You finish your PPCs and import it to your OMA to get your financial modeling. Your 3D is from SketchUp, is from Helioscope, while your 2D is from AutoCAD. So the client wants to see all of this. The document from your PPCs, the document from your OMA, the document from your Helioscope, then the document from your AutoCAD. As I said, the importance of AutoCAD is, in fact, how will I put it? I would say in some of the facilities, you realize at the end of it, the OMA, the PPCs, the Helioscope is for them to approve the job for you. When you just start, it's the AutoCAD that will tell you exactly what you need to do on the road. It's AutoCAD that will tell you exactly where each of these components will be. Let me give you an instance in Helioscope. Your Helioscope, if you are setting your Helioscope, if you see that you can give a clearance on the edges of the roof, 1 meter clearance and so like that. Can you set your walkway, the dimension of your walkway? You can leave a space in between panels. No. Can you set the dimension of your walkway in Helioscope? Practically impossible, right? So these are what AutoCAD will do for you. And if you look at the layout, the system I just shared with you, now the one I opened, one of our facilities, all everything that I share with you, that I show you there is done with AutoCAD. And your clients need to see this, because if they come to site, that is what they will use to access all your equipment. I don't know if that answers your question.
Great. Thank you very much, Engineer Hakim, for the questions. Because of our time, before we close, I just wanted to have your POV, your view on something, right? I was having a conversation with someone, was it last week or thereabouts? So I just want to have your own view on this general question, on your take, right, on engineers that solely depend, on the softwares now. They don't want to properly have the, let's call it now, the manual knowledge for basic system sizing, which I'm very sure you pointed out in your presentation that 90% of C&I is your design. Because when you get your design right, you have done 90% of the job. So you see now most engineers, they just want to solely depend on the softwares now to get their parameters, not actually, taking note of the manual way of knowing how to do these designs. So I just wanted to get your view on that aspect, Engineer Hakeem.
Okay, thank you so much, sir. So I, your question is, how will I say, like, I try to understand the question from, in fact, even from your own angle. There used to be that I've been in Rexy and I got all the same feedback. But it's of interest for everybody to know that I started this journey. I think the first thing I did is with Ascendant Solar at Ibadan. I've done personal projects, mostly residential. I work with my hand. Like, in fact, so there are some guys that are playing in our site, in our company. Maybe it's really the guys that want to look at it. I think is there and go like that, But what I used to tell them is that if you are starting from design and you are starting from C&I, it's as if you have a child and you want the child to start from university. It's not possible. If you don't understand the practical aspect, the manual design, the what is situated, you have not faced the real challenge. Because you won't have my feeling. Design is not something that is just go like, no. The way you look at it is that, okay, if I'm the one doing this. And sometimes when I do my thing, I will tell the installer, I share with them that look at this system. What do you think? Sometimes some of them will say, engineer, why didn't you go this way? And when I look, because at that moment when I'm designing, I'm putting myself in the shoe that, okay, if I'm the one. But I always like to have their own perspective too. That's why I will share with them that, okay, look at what I did. Because you are the one that will work on site. I might not be there, maybe the last day, and I don't want to come to site and tell you to start from the beginning. Right? So, starting from design or joining a C&I without going through residential or without going through the man or doing the proper training, it's as if you just have a child, you don't want the child to go through primary school and secondary, you want the child to start from university. It will be a total failure. So this is my input. I don't know if you get.
Yes, thank you very much, Engineer Hakeem, for that clear answer. Because I had that conversation with someone early last week, and that also pointed me now to. I just also posted a link on the RETI upcoming training. Rightly from what we have heard, Engineer Hakeem have said, you can't start, C&I without knowing the basics. It's from the basics you now move, to understand and use the software proper and better, and the software will serve you. So we have our training coming up next week, which will be focusing key on design. Design is a very key aspect in this industry, be it residential, be it domestic, be it commercial, installation of. You must know your design. And when you know your design, you can always, navigate around the software. So this training coming up, I posted a link. You can always share with someone, your colleagues at the workspace, neighbor, to come for the upcoming RETI training that is starting up next week, focusing key on design, and then a little bit also on introduction to C&I. I saw someone ask a question around, wanting to know more knowledge around C&I. So this training also, there will be an introduction to C&I, and then also the RETI team, we're also planning, making arrangements, for software advanced training coming up. So that is to say that the link is already there. If you have not attended the training before, or you know someone that you know that would need this training, this is an opportunity for that person. So before we close up, because of our time, we have already spent time. We just have someone here from Teresa from Ethiopia that will be the last question before we wrap up the webinar so that we can go about our business for the day. So she has two questions here. The first one is, what are the most critical design parameters that determine the long-term performance and reliability of commercial solar PV system in varying climatic conditions? What are the most critical design parameters that determine the long-term performance and reliability of commercial solar PV system in varying climate conditions? That's one of our questions. I'll just take the second one now. In your experience, what are the most effective strategies to optimize solar system design for both technical efficiency and economic visibility in developing countries like Ethiopia? I don't know if you got the questions, Engineer Hakeem.
Yes. I think the first question, what you're trying to look at, I think the first thing here, if you look at the slide, I made mention of procurement. The quality of your material, the quality of the equipment. You don't cut in C&I, you cut unnecessary costs, you pay for it in multiple. So the standard, the earthing, you see, I'm emphasizing on earthing. Earthing system can bring down the whole facility if you have a bad earthing system. So your equipment that you want to use, ensure you have a standard equipment and a manufacturer that have good sales after service. So once your equipment are good, then follow the manual, the standard. They are so each manufacturer have their own standard. Give and take. Let me give an example. For who are we? For the PT inverter. For you to arrange the PT inverter from one PT inverter to another PT inverter, you must maintain a standard of minimum 300 mm. Minimum. We don't have space. We don't have this. No. So if you need to have a good procurement strategy, then you need to follow the standard of the manufacturer. Then I give so many conditions like DC to AC ratio. Those calculations are very, very important. The characteristic cost of this system, you need to consider all the systems. Your climate, your environment conditions, Ethiopia is different to Nigeria. So is Ethiopia facing south, north? So you need to look at it. How do you situate it in the map? In Nigeria, my panel supports the face south because of our position in the equator. So you need to check for Ethiopia before you carry out your design. If you use your PPCs, PPCs will guide you, right? Once you click on PPCs and you start PPCs, it will tell you where your panel is supposed to place. So you need to take advantage of the software. You need to be genuine. You need to be original on your documents. Your procurement must be optimal. Right? You don't want to gamble anything. The system, you know the number of years you want to run this system. So I think basically that is what I can say, except if she has another question. Hello, Engineer Soma. I think I'm through.
Yes, thank you so much, Engineer Hakeem. Hakeem, it's been a wonderful section with you, and I want to say a big thank you to you once again for creating time to be part of this webinar section. I know you're a very busy person, but you honored the invite of Reti, and we want to say a big thank you, and we really appreciate you, and thank you. And to all participants, we want to say a very big thank you to each and every one of you that stayed through to the end of the webinar. I'm sure you also had a very great and insightful section here. And again, also before we wrap it up, the training coming up for next week, Monday. So if you have not registered or you have not attended any solar training before, there's an opportunity to get real hands-on experience from domestic to the C&I. You know, the train is moving now from domestic to C&I, and then we need to make sure that we carry everyone alongside. So be part of that training coming up, and we'll take it up from there. So the conversation does not really also end here. I've posted the link to the LinkedIn page of Engineer Hakeem here. So let's follow him, connect with him, reach out to him at any moment if you have any further questions. And also on our platform, we still remain very much active. If you have any follow-up questions right after this call, you can always ask the group, both on WhatsApp and also on Telegram. And I'm sure Engineer Hakeem will attend to all of those questions. And then all the section was recorded. So all the recordings will be posted across all our social media platform, all Reti social media platform, on our WhatsApp page, the LinkedIn, YouTube, X, Twitter, Telegram, so that we can always go back to it and listen to this interesting topic that we just learned. Personally, myself also, I know it's always a wonderful time when you have an Engineer Hakeem. So much experience, hands-on experience, field experience. You learn so much. I also enjoyed myself. I made some notes to add to, to my own knowledge and my own personal growth. So on that note, on behalf of Reti, I want to say another big thank you to you, Engineer Hakeem. It's been a wonderful time with you and everyone here on the call. Thank you, and have a very great day ahead. Thank you, everyone.
Thank you so much.